Good evening, good evening, everyone. Ngasi class hours koi ngarang the solid storm mani mechanical properties of solids ko ngasi na mechanical properties of fluids to wudui so koi ngarang to give the hapitang ko quick recap macha ma yeng ngasi aduga koi na kedoba fluids ho yare ko. Let's do a quick recap. Mechanical properties of solids to give ne ko ngarang do so chapa horaba chapi raktabi chappaje in gravity over is okay. Mechanical properties of solids ki koi si le question kya no pingan to give da see question number 7 8 9 10 to with the book the question number 6 for the ngang loi gram ne to wa so ngang to to si bo to gram ne ba so khin ngang to with do kai kai no ha matam da solids ki matang da ka chapter number 8 mechanical properties of solids longitudinal deformation, tensile deformation or shearing, then volumetric deformation kind of go. There is some definitions such as elasticity, plasticity, strain, stress, and strain stress pe marak kai relationship lay Hooke's law matungina proportion directly proportional oine kind of then you have longitudinal deformation at the nang napochi kedoba stretch or compressed option ba ka longitudinally compressed unica volumetrically nate tangentially phasing but twist or turn to ba. Then CGC we have the textbook to the capital Z or no symbol that, but again it's just the same. Got top of the CG symbol so next up volumetric deformation lay. So see kwengarang na grant na kaygumba kano tawning agazu class to Mr. Horagazu yengning agazu recorded session YouTube to upload to wunika NSH project and search the raw N for nature, S for science, H for humanity ka. So NSH project ta YouTube ki search bar the NSH project and search tawdam tholok kani ka. Then matang the stress strain curve tawgre the potential energy stored in a straight string tawgre ka. They makhata point a si compare tawgre ka Young's modulus, bulk modulus, and shear modulus ka. So see later. Then matang the CCA femur ka femur bone again, so it's not necessary. Anyway, so CCA na this is known as I-beam, and I-beam is the changi construction there na maru ko I-beam sa. So si tawgre then matang the question kara hot kre ka. So makata point na question kara lemo ko this whole as ka. So question number kya ta godam na question number 7 to godawa ka. So let's do it. Torzika. Question number kam to godaba 7 to godaba ka kitang tigat ka. All right, fine. Oh, I see some geometry. Okay, ka. Question the kay hayeng zika. The approximate depth of an ocean is 2,700 meter. The compressibility of water is this, and density of water is this. What fractional compression of water will be obtained at the bottom of the ocean? So fractional compression of water. When delta V upon V delta V upon V is equal to what? The approximate depth si pyramid compressibility of water pyramid. So 1 by B pyramid compressibility of water si can have the 1 by B which is equal to 45.4 into 10 to the power minus 11 Pascal inverse pressure inverse. And density of water rho is pyramid when pyramid is rho is equal to 10 to the power 3 kilogram per meter cube. So C is put on have on a queen have the pressure P is equal to erga minus erga B erga delta V upon V nebuka. Aduragadi delta V upon B zino in a palmagadi, you just have minus kedaba P by B nebuka. So again, minus in a neglect or CI now pressure say kaino kangde, but pressure is give formula 0 z H and amalika. So do the pangadi B givudi. Divided by B ni. So this is equal to minus rho di kaino rho di 10 to the power 3 layer z di kaino 10 losula and what's h di kaino height to 2700 meter to 2700 and into 1 upon b di kaino 1 upon b di 45.4 into 10 to the power minus 11 there. Adu ibi taragadi minus ibudi dum laser ni ka. So 10 to the power 3, 4, 5, 6 ka. And then 27 into 45 layer ni ka. So okay, 27 into 45, 45.4 actually. So 0.4 is log 40. Thumb 0. Noina thumb gear zu yai, log to ke zu yai ka. Tau zero zu dum tau si. Kay heba si giza 27 and then ke deba 454 into 27 tau. 7 4 28, 7 5 30 5 and 7 4 again 28 ka. 8, 19, 11, 28, so 31. Yarba. They 4, 2, 8, they 5, 4, 20, 4, 2, 8, 9, 10. So 8 lerni, see 5 lerni, see 2 lerni, see 3 lerni, 1 lerni, and then see minus 1, 3, 2, 5, 8 lerni. Now this will be 1.32 lerni. 1.3 258 into 10 to the power higher ka. CC 10 into the minus 12 never. So 3, 4, 5, 6 lane ka. 6 8 12 target minus 6 lane ka. So 10 to the power minus 6 lane. 10 to the power minus 6 lane. So what fractional compression of water will be obtained at the bottom of the ocean? So there seems to be a mistake. Oh, CC kilogram. Okay, kilogram the chemical meter, Pascal chemical. Everything is in perfect unit. So in a chemical CC the in a 2700 already 0 is a pool 3 then 3 4 5 6 10 to the power 6 never. Rho ZH 1 by B. 1 by B. This is layer for 10 to the power minus 11. I do with the address. 6 ka minus 11 gati kay tani have it okay fine. So C point senang na point nam gi har gati 10 to the minus 6 to the ka adu di asila na ka 1 2 3 4 adu 10 to the power minus 2 tai chumme ka tai so 1.3258 into 10 to the power minus 2 tai ba ka. So C pot C karam baga khwaidi naknai har gati 1.3258 di fractine 1.2 ga 1.4 ga su moini baka naknadra karam badana hena naknai har gati 1.3 makti natamina ID 1.4 khalage ba. So 1.4 tabre yung ma'am
1.2 oina tayo sir.
1.2 oin taya.
Oh sir.
1.2 tai dun tak padi moina sumai lom do male 45.4 se 45 tel ka keno to bai ta kai no si 13 1.32 ji pick paina. But again nataga sir na keno to bu sure ba multiply to the 7 4 28 7 5 35 36 37 7 4 28 29 30 31 chumi keno then 3 jam putar ko ta chumme se 1.32 ga den ba. Now moi gitagi combine tawdana keno tawri no have to moina pangtaw tawsilage ta yabra sise have the question number kyan zikita I'm sorry question number 7 ka 1 second 27 into 45.4 ne ka job money ka 27 into 45.4 si taw matamda moina 1.2 tai do kamay no moina 1.2 tai do keno taw bay ni 45 into 27 ga tarom no male ka dugin. So 45 into 27 kay gumba tꯧba taragadi kai tani habada 7 5 35 3 in n 7 4 28 29 30 31 4 2 8 19 11 sibu taine. So 1 point this so 1.2 the hen pakai maina kano 0.4 the load of target 7 5 35 and 4 28 28 ko 29 30 31 or 4 ko 4 to 8 19 and adudi ke ba 7 4 28 ko the 28 or the 38 41 so cc 1.215 type ko 1.215 type 6 sorry 1215 type this uneasy into the 1215 type ko aduna moina 1.2 lotion be one but 0.4 0 the 1.3 then chawbunina 1.4 na din na but I don't know, it's very strange ko my 1.2 low is kai ngong de c nangna 0.4 low to the cd type 28 38 39 40 41 4 to 8 9 10 11 12 so sumain to 45.4 se si low to the cd type ko aduna karamba low ge have the depend to re so moina 1.2 ne choose to re 1.4 1.2 zu ta de sing di ka 1.4 se sine di hena naksale real answer di si sine correct answer di yan data de me ya bra
how moi g to 9.8 low way
moina z 9.8 low z 9.8 si khoi low na te ko specifically moina 9.8 low na palam da tar gadi low na de te na dum low ni ba moina kai gum 9.8 low na exactly palam ma ba 9.8 low na adu de khoi 9.8 low ga ni ba ko kai gum 9.8 low na palam da tar gadi khoi na te na dum low ga ni yan dai ko sa ha ja si tham rule ne khangjela aduna hoi moina kai gum 9.8 lower magadi somda 1.2 ne naksal lakta ba hedi picture amni na ko yare ko question ma kadang to da matam am sang thok re so so sumain tare yengo si di ko these are minor any problem matter but mo si am di positive option ga sana de I di moina use z equal to 9.8 haram gadam ne ba moina 1.2 ta haning agadi adu jong ta han de mointe se ko current problem mointe se. Anyway, let's see. Question number question number 8. Copper of fixed volume V is drawn into wires of length L. When this wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graphs is a straight line ice? No, isi di kangadra. Tawdusi adra tawdira. Sazainara. Lakshmi, Sahila, Saitabos, Yayoiba, Christina, Anjali. Haro.
Hangani, sir.
Kangani ko question number 8 sa. Question number 8 si toning ba mi yaubra?
Tawse, sir.
Hints kada be biram happetang tawse
Happetang
Tawse, sir.
Tawse. Okay. Okay, guys. Okay, isa kitang Hazel. Copper of fixed volume is drawn into wires of length L. Into wire of length L. When this wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graph is a straight line? Obviously, the kana graph to straight line no have never. So now we have the straight line has have the ratio to constant now ratio z constant z karam but we never line straight over kundi bra c line straight the bra mala kitang payo mala pyramid so all right fine So fixed volume B is drawn into wire. When this wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graphs is a straight line in? So delta L go 1 by L ga na have F by A da. Karamba straight line when you have the Young's modulus C constant nina F by A harga delta L by L hayudunyabaka. But when F by A the piram devaka. Adudi sigisidi kai kamaina khanbe sigiside. Let me think about it ka. Sisi kuna kai khanbe habda moina constant we hello haibnebaka. Aduna y the budi mana hangadoineba kain tawduse. But y the mana hanba matamda kamaina to y the mana halagadi FC F the L laga A ga delta L ga the volume is fixed or in higher yes nice ka ada interroga chatkadoineba ka. So now this is a very kidova nice question ka. Kamaina to we have matamda moina sida clue ma pirameba fixed volume na ka yam phajai question se. Aduna kaido we have matamda sir na kamai hot kani habda yz constant idana ka. Aduna F into L harga A into delta L la ni buka sumai le ni. Now aduda kaido we have the again CC constant natte atai di constant natte, so now y le ni ko F le na. Now sigi A sida aina kai gum sida L square harga di A into L zi kai A into L la ni. Sorry, si delta L and delta L in la kromale. Si la le. Delta L z mapanda la ka da buka. This is A into L, then delta L la ni buka. So which is equal to harga F by volume. This is V is a volume nika. And then we only have the L square delta L haita. Auna sida we have the when extended so constant force is okay hai moina constant force hai ba. Auna this is also constant, this is also constant, this is also constant. Loine mo constant nga tani Young's modulus constant idana ka. Then it implies I can simply say kaidova delta L is directly proportional to L square haita ka. Auna delta L sompura ni ka, so L square directly proportional. Adudi kai tani option number B tare ka. Gyan tabra tadabra sige ma'am.
Tai sir.
Tai ka. So sisi akoina kamaina khala ino habda mana ka. Id akoina just asigi magi actual magi chumnagi formula sidum pansal leba ko pansal mamatam sida problem na easy kaina habda force ka A ga ji adi C delta L ga mark the relationship like the y with the constant khangena F ka A ga di constant ji oi di have ji question dai thi de question the F is constant oi har me but A di oi de ba A the constant oi ga di L am into toxulary area of cross section into length volume ni dana aduna A the L am into tori mathak ta ju L already lecture me amaga into tori L square la ni ka so sumain tor si ta rai ne ba gyan ta bro me yani how we got okay fine great so C graph ek to ziare ka okay so kana yawe kenu to bra seila gyan ta bra seita boss Lakshmi Anjali yayeba taika
sir.
okay fine luncheon bi tat kramale odagi kana na tat krise kaninglu tat kre ka 6 7 8 odi kana na amagu tat kre to is internet no ita be okay. Anyway, matang the kaino question number 9. The following 4 wires are made of the same material. Which of these will have the largest extension when the same tension is applied? And Chidi kang dadra. Chala henaro. Tize. Kang dadra harasi. Same material, Young's modulus is in chapman agadeni ka. So largest extension the gram than lakane ever. So delta L is equal to kay habi F by A haraga kay L by Y. So leibra leite leiko. So aduna which one of these will have the largest extension when the same tensionary forces chap manarga de have ka. Avuna delta L is directly proportional to haraga L by A neva. Avuna L by A si kanana khwaiden chawi di yengaseba ka. L1 by A1 si kai tai 200 by 2 mm ka. So 200 centimeters in keno kayuma millimeter don thogadi shmai lani ko. So 1000 tare. Mathang the L2 by A2 di kai tai 300 to 3000 by 3 ni and she su dong 1000 tar ni ka. Mathang the L3 by A3 di kai ta ni again she can diameter ni ka. Sorry diameter ni area na table ka. So anyway that doesn't much difference ka. So in a CC squared right also again half square 1 by 2 ka. Tau zero mm the container ka. So 2z diameter z magi radius t1 ina 1 square hai tare ka pi into 1 square hai tare and this 1000 by pi tani delta L1 by A1 se ka pi 1 square hai tare. So mathang da A2z kai tani have da pi haraga 1.5 square ne ka. Yep, yes, 3 by 2 the 1.5 ni da. So so is 2 to 5 by 10 hai ta 15 square 2 to 5 by 100 adum tobo ka aduna masigi di amukka khadi nungai to is ka 25 na to 25 into 4 and I see the 4000 lani and then 25 into 9 2 to 5 lani ka. So 4000 by 9 lani 9 pi hai ta. Not a very good thing. Now 50 is the 50 is the we have the centimeter c in a millimeter don't okay c lani and then magi area is the pi r square ni ko hai ko length la sigize mani area is in a mm na tra mani. So area is 0.5 to 0.25 square. 0.25 square is 0.0625 tar ni buka. So CCD kai tar ni have the 5 1 2 herga 1 2 3 4 divided by 6 to 5. Ito nung right resident. See, and just 4 25 into 25 to 6 to 5. 25 into 4. So I do get the 5 4 20 20 into 4 the 80. This is about 8000 8000 by pi. Chumbra 5 4 20 20 yes 20 into 0 2000 into something like this 8000 by pi lani. This is A3 hai tare ka. Sigisina 9 jina ka gadi kai tarne of the 9 of 436 natra. Then 49 436 49 436 40 something like that. So smahin chalan isine hele. Mathang the last kis kai na last kisina 1 second ka. Ito is it. Swear ba. L4 by A4C pi r square lakadin ka. L4 the 1000 layer ni aduga 1 mm. How? Haro.
Area je. Keno pi r square. Oidora.
Mani keno. Area the pi r square na tro. Area of cross section ne sida. Kay
Yare.
yarba. Okay. So 25 into 4. Do the 4 1, 2, 3 divided by pi. Now, which of these will have the largest extension when the same tension is applied? I'm gonna 8,000 by pi. I'm gonna this. I'm gonna this. I'm gonna this. Oh, this is not quite here. So option number C is it. Yung
Tayo, sir.
tayo option number C question number 9. Option number C. Yare ko, tare ko. So question number 10 tawsi. Haziki to 9 do yagraba mayam leni no response. No yadragadi yade harobo ko. Sir, amko explain tawge sigi si lon yarba yadabra hinaro. Seeing na di kumo ko.
Yeah.
Yare ko. Okay, fine.
2,000 or 1,000.
Kaya ba?
Asi L1 A1 gitu.
2,000 zira. Oh, see, 2,000 chum. This has to be 2,000. So, 1,000 on to me. Masaya na 2 na yen giba ito niya ba? Hambada. Kara, loto ko. Anyway, fine. So, yahalasi. Matang taursi ko. Sige question si Dion. Kay hano si Dahaja. If the ratio of diameters, lengths, and Young's modulus of steel and copper wires shown in the figure are this respectively, then the corresponding ratio of increase in their lengths would be in hypercar. So, okay, very simple. Steel ki diameter of steel by diameter of copper is equal to P ka. And then diameter length of steel by length of copper is equal to Q, and Young's modulus of steel divided by Young's modulus of copper is equal to S, P, Q, and S respectively. Then the corresponding ratio of the increase in their length will be delta S, delta L steel and delta L copper is equal to what? This is the question. Now it's a very simple question. Kaino sir, very simple question. Now steel gida steel the chingthai kanana no 2 plus 5 7 mg divided by magi kedoba diameter haitare ko. So diameter square amarom di constant pi nunglani then ds by 2 whole square kailani ko. Aduga is equal to harga Young's modulus of steel and then delta L of steel divided by total length L of steel. This is equation 1. And then let me just shift this a little bit up. And then we have the same thing. The copper gidi only 5 mg katangni ko copper the. So 5 mg divided by pi harga d of copper by 2 whole square is equal to Young's modulus of copper delta L produce in copper divided by L of copper. This is equation 2. Aduna dikit only have the equation 1 divided by equation 2 gives Kaitani have the 7 by 5 7 by 5 aduga makhagi ds square si layrani mathaktana dc square lani makhadana ds square lani is equal to haraga sidesida kedoba ys by yc lani aduga delta ls by delta lc lani aduga kailani habda sigi makhagi sina ls layega and mathaktana lc lani ba. So adu ergadi moina putohaisi kaino delta ls by delta lc is equal to delta ls by delta lc is equal to 7 by 5 into ds dc by ds se kaino 1 by p ko so makada p square lani and then lc by ls se kaino q lani makada ls by lc se ls by lc se q ni makala ni lc by sisina kaino sisina sisi piram bro o lc by ls natra lc by ls ne ko adu di asom the q la ka de q sure auna 7q by 5p but again what about s sina moi puto ai kaino y gi di puto trika y sc asom the pu gi do ni na yc by ys la ni ko so the 1 by s la ni it has to be s here ko sp square how the 5sp square 7q hai ta option number c se ta brio yon tamam
Đấy, sir.
ai ko option number b ta ga da ba ko option number b yarba ma'am loinamak Lakshmi yarba
Ôi, sir.
ko Lakshmi mathan khumai ji kai gina Anjali adagi yayoiba Saila
Dạ. Này.
yani ko gyanta hoy ko lone ma
Rồi.
okay
Rồi, sir.
okay fine so let's proceed so makha tana kuina option number 10 is kai ta b ta ko yare mathangda we have kai chapter le mathangda mechanical properties of fluids le ko so pressure Laplace streamline flow Bernoulli's principle viscosity kai ka smaina khara le ka so adu do khara takshal lage ka so this has to be chapter number 9 mechanical properties of fluids ka so Torzi now it's a very simple chapter ka so first we have the pressure inside a liquid column pressure inside a liquid column ka so cc combined to we have the yang asika now si line phaiba mali in swing with me pay no problem anyway there I go so let's say I have a liquid container so phai kanu phai biate phai is I have a liquid container like this now we have a liquid container si the liquid si po yaure and khala se ba adu ergadi we have the aina point ama si point sida labor pressure si kya no na puthoningagadi we will have to consider a cylindrical shape ama ko khoina consider torni ba so yengo we'll have to consider a cylindrical shape and magi pressure difference so yeng se ba mathaka makhaga so let's say this is PA sina makhada force maybe PA again like PA di harage P1 harage P1A harage aduna fani force natraga sidai sida this is F1 and some side na kaino F2 le ni bu aduna rakani ha matamda hazik akoina CC free body diagram red no in season different but okay anyway white so F2 zikanaga kaigama ni have the F2 should be equal to F1 plus MZ never CC kangra have the sigi cylinder se, let us consider an imaginary cylinder inside this liquid column ko. Liquid, any liquid ni ko. Any liquid has, it could be fluid, it could be any gas, it could be any liquid ko. In general, it could be any fluid haitare ko. So we have sigi manung jida aina kaiguma si point ama consider to seba. Sigi point si mazi equilibrium de lagi haragadi mazi leng oigi haragadi kaidoni ha matamda sigi equation si mana follow to with them never got. So sigi equation in high kaino habda, if we consider a cylindrical volume or a cylinder a liquid column of height, let's say of height h, the height, this height is h, and then magi area of cross section, let's say the area of cross section is a. Adu ibataragadi kaidoni ham tamda akoina magi haidi sigi points ma rest lagi haragadi mangonda laiba forces sing balance balance tauna gadam neba aduna makhadagi force ina kaino f2 mathakta ina f1 plus kaidoba mg amako. So what is this force f1? Have the f1 is the force due to the pressure nebuko. On f1 ji kaino have the p1 a neba kaino di pressure have the kaino force by area nebuko. Aduna force have the kaino have the pressure into area neba gyan daita de taiko na force have the pressure into area, so p1 into area, and then magi mass the kaino have the rho density into volume, volume the kaino have the a into h, and then z. The some site na kailani have the some site so force the kaino pressure into area from the lagani, so makagi pressure in a p2 tonjalage p2a called a alone cancel sakrakan kaitane have the p2 araga kai is equal to p1 plus rho z h star. Gyan taita this is a taika aduga if p1 is equal to pa atmospheric pressure, then p2 minus pa is equal to rho zh. Have the kind of the difference in pressure the difference in pressure between the kaidova the difference in pressure at a depth d and the surface is always rho zh never. Ana rho zh tagi have nang kaigumba surface tagi ko liquid am lere adugi liquid column ji my surface tabudi atmospheric pressure dum laigani buko. Any kaidova liquid am lere, so sigi liquid column ji is the my surface tadi kai laini pa laini ba. Now nang na sigi surface idagi nang na suppose let's say you go down inside the liquid up to a depth d. The pressure kai laini ya matam this pressure is equal to pa plus rho zh haitare ko. So si ji khangadam ne ko. Mayam sir na ji hai si loina ma gyan tabang ambra gyan taubra. Lakshmi, Sahila, Anjali, Yayoiba, gyan tabra sir na ji taiza.
Sir, force to gitu.
Kaya heba?
P equal to PA plus rho GS gitu.
P equal to PA plus rho GH si gyan ta de hera. Kenu zidi gyan tabra. Songi zidi gyan tabra. P2 zina pressure at a depth kani at a depth D hagira at a depth H hagira dudu ne bako. P2Z just P nian lower sigi point ji leba pressure du ne bako. Aduga PA sina magi kwai mathak lay pressure du ne ba. Have the aina kaido we have the kahesi again noina ne sigi cylinder se. For example, let's say amtanga ye ke ka. Suppose let's say you have a cylinder like this, and then had the CC Aquina bottom side cylinder nico. See the level pressure putok and color zeba. Aduga magi liquid china, let's say liquid or fluid china sigo yawa and color zeba. Adu regarding see pot see anywhere shift away. See the pukala see put her wherever mafam shift away got the nang see the pukalaga, and then kedo we have the sorry. So adumaina laigaduini ko aduna sarna sida p2 gi mota pa lori se sigi pc manung da laiba pressure dune ba si p2 dum har si ba p2 is equal to pa plus rho gh har si ba have the noina kaino manung da changma matam da ne swimming pool gumba pukri gumba or part gumba da ising manung changma matam da pressure si sum wang khalakani ba ko noi nakong da na ba natun da na ba ga taw bane ba so adu du kayam kenani have the atmosphere or surface level pressure du da gi mana kayam hena chawgani hargadi surface to the level p1 p1 je sikuri surface level nate at height h tani but kay gumba du sangduroga surface po yoraga di height tuna adu surface level pa du da rho gh ka chap manani ba hadi pa plus rho gh ka chap manani ba gyan ta da bra habidi p2 is equal to pa plus rho gh hoini ba ko natra or harga you may say this one chini chap manai gyan dai ta de
Tare, sir.
Bye, sir.
tare ko seila yar ba
Tare, sir.
yayi ba yar ba
Yani sir.
yani ko lakshmi ji yar ba
Bye, sir.
okay fine so aduna sigi concept si kyamuk maru ge habida ko si se habidi sir haiki ko let's say noi ke ba yumda noi da syntax mem lemni loktak ki syntax sangai ki syntax blah 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 ko la inter syntax mem lemni noi yumda ko so let's say suma inter syntax am le ko amana syntax si kitang wang eta so let's say suma le ka suma inter syntax si both ko cg amazina wange amazina pa ko volume di chamane ko now ani si kaido we have the noina pressure gi oina khallaga di karam mana pani syntax ani se syntax a or syntax b chamane ko si su kaido ba let's say this is also 1000 liter this is also 1000 liter so si gi syntax ani si noina yum thakta thangalaga ko sijina bayo indi karam mana fai hero
B na, sir.
B na fai ko according to Lakshmi yayi ba karam mana fadau mali yum matakta thangala sina bai di
A na pagado mal.
A na fadau mali ko Saila karam mana fadau mali
B na.
B na fadau mali ko Anjali di
B.
B na ko okay fine kana quite first Lakshmi na ko makib Lakshmi B na fadau mali ji kai gino
Sir, height khara yamakpagi.
very good height kra yamak bai ko very nice maji kai na nangna water si chamana na si po fill to gudoi ne ko water si da ju si po fill to gudoi ne ba au si di mai height ti le ko ma di pak kolom da sat paina mana pak ta bi da ma di kai do wa sang bolom da yung bolom da sat paina mai di height yam wang ba height yam wang bani na kai do we have the si da lai ga do pressure je si da konjin nam pa le en khala je ko au si gi konjin ji da gi kai do wa water si flow to ka doi ne ba and then sigi is konjin nam palen kala si konjin the water si flow to ka doi ne ba sigi height si the h1 let's say this is h2 auna h1 is smaller than h2 auna p1 would be smaller than p2 kai you know the pressure is kai no p1 is rho z h1 never and some side na p2 is kai no rho z h2 never auna rho z water gi density rho aten chap na g su chap na but h1 jina sidana tele si h2 dana dama dam sang na p2 jina kai dorani have the p2 jina dama dam hena chawrani pressure chaw ba ji kai na ising ji hena kan flow out tor ka dine ba ko so yadra me amene ma gyan tar ba yayi ba gyan ta hobra
Tahu sir.
tawi ko aduna always have the syntax awang mana fai adu noina amka yum gi thambagi mapangan gi adu gi dai har ga spread out or oibaduna amka hena phagaduni adu gi ko but again noina watery flow gi oina har ga si sina fai ba ko adu yuan but again syntax am na lumgen lum of the kishu kai di ngasai gi na gi construction do the kenta yam kana effect of the delay so adu si kishu kai di adum always choose for the one which has taller height tare ko adu ga seng bu di ka wa ba anyway So where were we? Okay, now. The Pascal's law the pressure streamline flow and Bernoulli's principle so 930 die. So question number ni what say do nga sige di kano ni sir kitang tired already na question number ni wala lashilas. Masayin kano to masayin net yada wifi di nga si yade ko sir gi phone gi data de sir mo sir gi mobile data de gi to bani si class si. So anyway, a U tube with both ends open to the atmosphere is partially filled with water. Oil which is immiscible with water is poured into one side until it stands at a distance of 10 mm above the water level on the other side. Meanwhile, the water rises by 65 mm from its original level. The density of the oil is. It's a very simple question. Yam luba man be wani. Tawzira tawrizira. Sa haina ro ngamgadra tawzira. Tawzira. Okay, fine. Tawzi ko dia. Yung sida sa tawrage yung. Sida channel so. Sida in tawrage ka. Save kung ye kita. Ye ro ge sida ng ya. A U tube with both ends open to the atmosphere is partially filled with water. Okay. Oil which is immiscible with water, or some sites in oil never is poured into one side until it stands at a distance of 10 meters above the water level. So see the kitang wang kakalevel ka. Meanwhile, the water rises by 65 mm. Water is in a kitawang asagi initial sea level 65 mm kakalevel ka. Okay, the density of the oil. Oil ki density ka inuwe ka. So very simple. Now, Sigi point C Sigi sida the pressure is same height in a chapmanabam to a now let me write like this. Pressure at B should be equal to pressure at C. Now pressure at B the atmospheric pressure plus araga kailani have the rho of oil into Z into height H. Height HC height HC I will say AB should be equal to pressure, atmospheric pressure plus rho of water plus height surface is EC it should be EC. So very simple P and the density of oil into Z. Z what is wrong? Rho into Z into H and plus story is so C to Z ni so Z so crack and we have the height of this so C have the 65 plus 10 75 mm tani aduga amazidana density of water C ni 1 millimeter the low one in density is 1 gram per centimeter cube never 1000 mugla ni might be 1000 gram per millimeter cube and then into HC water gidi 65 in is the 75 low chumbra lale C 130 le CC 140 we this has to be 140 I did my height say C is the 130 plus 10 this has to be 140 and this can always low to this is 130 how the rho of oil is equal to 1000 into 130 divided by 140 as I see cross see the fraction with tiny I get this hot pada what patam ni 13123 divided by 14 the 9 low abra the 9 4 36 919 10 11 12 yeah 9 4 36 so 919 10 11 12 so do the 30 minus 20 64 40 later so 14 say 4 3 12 313 4 yaroi ko 3 na yaroi 2 na torni so 28 ko 28 oragadi 40 dagi 28 kaido di kai tarni 2 and 1 12 tare ko daidi si point nama si lani so oragadi 14 na 8 tarni ko so whatever so 8 oragadi 8 4 32 8 1 8 9 10 11 1 1 2 so sida 9 to 8 point something like that so 8 layani point namani ko daidi 0 mapani something so this has to be approximately equal to 9 to 8 haitare ko and then cc kaina beta gram per millimeter cube ni gram per millimeter cube ni so cc it won't make any difference nang na cc kg on thokpa matamda amazina 1000 meter cube lakatra kg on thokpa matamda but I get 98 98 tabre yung myam 98 tabre
Sorry, sir.
like so main oina crux cc gi sine ko noi sir na si solve to is gyan taba ngambre ngambra khwaidagi mar khwaidagi mini wari se pressure is same height the pressure manaiba si pressure at b ga c gi pressure at b ga pressure at c ga same line the lay uneasy manabam thweba so my height to the 65 plus 65 plus 10 over so then only 65 plus 65 katang over ko so yam luwa man one is in live question ko adu one yanerbo
Yeah, sir.
Yes.
Yareka. Okay, fine. So 1 kg per meter cube harga masisi aina ne sumaina sumaina yam wana hoto sopadi problem is later na ai sumain to gyo mai kai hai 130 140 natra 140 millimeter ne or 140 by 1000 kilometer 140 by 1000 meter ta this adu sis na kai na sina 1 kg per meter cube to on thoke ba ko ina nate 1000 kg per meter cube per meter cube to dina 1000 kg la kane adu sis na kai na the 130 by don't know I get ready 130 by 1000 erga meter la ni ko so adu do the have to say meter guy you have to say not to have say so this is the masamatan kaksha grain ko du masai dum ta 1000 into 130 divided by 140 or this is so which is equal to 928 yani ko yarbo me am sikise kanam khumuktre kaino yarbo harga yayo ba yarba
Yeah, sir.
kaino sir na noi
Yani, sir.
doctor to di kanam khumukti kaino tadro ne hey recorded session ne tabda nungairo Seizing methodology, two non-mixing liquids of densities this and this are put in a container. The height of each liquid is h. A solid cylinder of length L and density d is put in the container. The cylinder floats with its axis vertical and length this in the denser liquid. The density d is equal to and have a see question you know taptai luram dongwale. Lubra sigiza.
Luisa.
Karaluya.
Oh, sir.
Okay. All right, so let's do it. Okay, I put it in container. So I have two liquids, non-mixing liquids of densities rho and n rho. n row, n is greater than 1 haragadi n rows in makhada thangani buko. So let's say sumaina layering khalasi aduga mathakta su liquid ama laygadwini buko. Now the thing is can have the makhagi liquid china kitang denser warni mathaki liquid china kitang par ni tareka. So sile. Now mazi it has to be separated by a thin line tareka. So the idea is the height of its liquid is h, okay. So this is also h, this is also h. A solid cylinder of length L and dD is put in this container. But the cylinder floats with its axis vertical and length PL in the denser liquid. Okay, fine. P is less than 1. Okay. The density D is equal to. Okay, density D of the cylinder. Cylinder density is D never. Alright, fine. Alright, so sigi question si kitang phazagi davani sarna ka na what give the clarity kitang what kivani hot pa yada udi natte ka the sumaina were modi hi na phazani have wada adu diwane ka. So sigi question si Archimedes principle the base of question is sarna no the Archimedes principle tak tradi yaroi. So Archimedes principle si kitang yam line haige ka aduga ngasi classification be yare Archimedes principle ta ga no the kidoba haziki question do maga ka solve the Archimedes principle na haziki no have the body amna fluid amada float to matam the ka mana upward force of buoyancy ama fange ba ka adugi upward force of buoyancy da adudu kaiga manai have do adudu ne ba ka. So okay, fine, ka let me write the statement. When a solid, it has to be a solid ka. When a solid is partially or completely immersed in a fluid, immersed in a fluid, it has to be a liquid ka. The body, the solid ka. So the solid experiences an upward force of buoyancy whose magnitude is equal to the weight of the displaced liquid. Yandai ko sargi sorgi screen mapazi no the kanjan dabra mataki mapazi kanjan bra kanjan level ko. Okay, so let me do one thing. Kanjan lagadi na no the no idea ko kanjan draba
kitang kanjale
kitang kanjan level ko. Okay, do we targadi kitang kanjan sifa na ba no ida kanjan draba zikti kanam ko magtre sargi screen ji kitang kanjan level kanjan draba zikti
Sir, ID adong kanjin.
kanjan dia
Kanjande sir.
kanjan le sir hero kanjan de sir hero
kanjandre sir
Sir, ID kanjin diye dong.
kanjan diego ka. Okay, yeah, kanjan adudi kanjan ragadi myam kanam do kanjalam maroi adudi ka. Anyway, so silai ko sisina haining is kai no have the nang ne no si dum yum da dum no si haji tor jani patin namda ka ising galor ga ta nang na kai gumba sumaina nang na pot ama si thada matam ji da ka any substance ama tar lai re ka adudi si gi substance na taw matam da ke do have the mana water gi manung or any liquid ki mong chang pa si makha gi portion je si gi saru ki si gi volume je let's say si volume je v1 eba auna water gi volume aduga water gi density sina rho ne ba ko aduri mangon da ne upward force of buoyancy ama fb ama actor kaneba adugi fb dugi magnitude to kai oini ha matam da ngasai gi lupsaliba saruki volume do adudu lowro aduga water gi fd yani rho into kedoba sigi volume ze ko manung da changi ba volume zi wani aduna ke hasike the rho into harga delta v has manung da lupsaliba saruk se ko into z hai ta cc upward force neba sigi buoyant force am phang neba gyan tai ta de me ngau bra kra
Amtanga.
amtangan jira okay
Sir, ay tadre loy chapet tat uri.
re ba ko nai ko ta ni yar ba sikte tar ba sikte no response kai gumba let's say nang na si po si ne water si pik thaleng khala je ba ko aduga nang na si gi sida water si soin flow to thora ni som na kan da flow to reng khala je ba adu nang na sida kon ma sam da yare ba ko aduga maji ke do we have da si gi sang si yaure ba sing je sida gi flow to thora ni kai num di si gi nung je nang na thada ba da ta re ko and then song gi sidi mangon da ising gi nan tharak pa ya da na ba nang na si gi sida khajal la ta som di ko dusuga so aduga sigi na kan sida ising gi flow to thore adu di ke do ne sigi ne buoyant force upward to fangadru buoyant force sida displace to thore free da tarai ba water ji si gi weight to adu di gi weight to mana ne ba this w should be equal to fd ta ngau bra anjali tat kray
Tai sir.
tai ko kena to bra se suppose gyan tabra lakshmi gyan tabra sahila gyan tabra sir nining is it
Tai sir.
Tai sir.
Ay, sir.
tai ko okay anyway second let's say ingundia kinoniko waters for example cgz kinole ko ingun zaram le ko ken cc da noi da higher gadi kay ha dun noi gyan tab numai gidra taro idra khandi ko waters this is again not a very good one so I have a container and C container is let's say water is C changs bo yawring khala se ko let's say up to 400 or 500 ml bo yawring khala se ko now C 500 ml bo yaw matam jida kaida we have matam da aina kai gumba C something bol ama thadare si manung da ko thada matam jida kai dawni have the mana water khre displaced tawni dana so maji manung da loop khibe yai tawraga leibe yai ko we don't know yan dai ba ja loop khibe yai tawraga leibe yai but ma loop kera tawgera mana water gi khara di water gi kedoba amount khara di kedoni have the mana displaced tawni dana mana changjela kuma tamda ising gi level tu ka kedora kani ising level do matak ta kakhala kani dana yan dai ta de habdi nang na ne water da nang pura ma thada matam da ising bucket or ising bottle or anything ising gi container ising yabu container am da nang na any solid am thada matam da ising gi level du kaino to khala kani dana khara kaidor kani rise to khala oidro khara
Torakani.
tor kani ko ising gi level je khara hengal kani bu ko rise tor kani ba so hengal iba saruk to adu hengal iba ziki liquid tu gi volume duga nangi ziki solid to adu dugi volume duga hedi water gi manung da sanction bi solid tu volume duga ising hanagi original level de hengal iba gi volume duga chap manani bu ko so aduna adugi hengal iba volume do adu dugu displace liquid ko eba or displace fluid ko eba du do gyan tai ko auna sida haiji aina nei the screen share su tawdre du ai sai tan da yeng le ko adugi hengal iba saruk to du displace fluid ko eba ko aduna sida haiji kain habda when a solid is partially kai heba okay. So when a solid is partially or completely immersed in a fluid, partially or completely manung the pull up loop the solid loop piva solid to partially tower legera completely sink to gera whatever lining formation but haziki solid to ne mamon the upward force of buoyancy phangane my weight to handarakani buko kaino the upward force ama pikaleva adu upward force ki magnitude kai ga manani have the weight of the displaced liquid hay mana maram oiraga mana changchalu budi isingi level hengala idana hay adu hengat kriba isingi level to adu volume do adu dugi weight to abdi azigi liquid to ni ko aise displaced liquid to haita adu dugi magi weight to adu the upward force in a buoyancy in a phangakani boko si sibu Archimedes principle ko eba gyan tabra myam sigize
Taja.
Thank you, sir.
like okay fine so adu du neba aduna si neba Archimedes principle haise so Archimedes principle is also known as the principle of flotation jo hai boko so let's say Archimedes principle haraga ko si line gase ipai pai ba male interest ni chumma ba also known as the principle of flotation principle of flotation support ama float tawni tawro hezi magi buoyant force na kaidoba magi weight tagi helagadi float tawrni buoyant force na weight tagi taragadi pot to float tawroi so okay so sigi dum sida lecture na ka duba teji ka jingjange sigi yaga da jingba yaga is equal to the weight of the displaced fluid and liquid and so this is known as the Archimedes principle aduna Archimedes principle ji khangagadi si question ji hot si ka mathaki ji da hol again mathaki sina kaino habda man displaced to budu ji mathaki da ka rho L natra so the cylinder floats with its axis and length the rho L in the denser liquid have an ka na magi weight say my weight see area of cross section ji ANN khalagi ka aduga magi the density in the density D is equal to have a ka all right fine so dA density into volume so A into L so see mg this should be equal to haiga makha mathakisidan hairasira mathakisina kaino habada density z mathakisina rho into magi area of cross section and magi sina rho L or D kidoba L minus sorry L minus PL L minus PL into Z plus harga N rho A harga PL into Z C tagadam C noi gyan tabangam brangam dabra C line se this is the weight of the solid and this is the mathaki ka FB buoyant force due to the less denser liquid buoyant force 1 plus buoyant force 2 neba ka habidi sigi sida mangonda sida phangadab sina buoyant force 1 ni and sidai sida ju phangadab sina buoyant force 2 neba ka and aduga moini ji jingtarakadab sina kanan jingtarakani weight na jingtarakani w na kyan taita de taiko so g loin chat kre aduga if you take a zu loin chat kre ka aduga you can ka sigi question ji loidore yung munna ka so if you want to find D then here noina sidesida kai leni have the rho lerga L common lorga di 1 minus P lere ka plus n times of rho L P lere divided by L ko. So LZ nangna cancel out to yare aduna sigisida akoina kaido we have the this is rho minus rho P plus N rho P tare ko. Ana kaido main rho z na common law ko. Rho z aina common law taragadi 1 plus N minus 1 whole P times rho tare. So option number kay tare si there. I think in this option number B tabre yung ma'am. Tabra? Tai ko. So sir na solve to igyan tabre yung
Thanks.
Tai sir.
tai ko. Sida no ina khangadaba amna sida yari with W say this W is kaina, this is weight of the solid never. Have the weight of the kaidaba cylinder which is a solid ka. And FB1 in a kind of buoyant force in the first liquid, have the in the lighter liquid, and FB2 in a buoyant force in the denser liquid. So mind us of the when Magyan Tahubra Lakshmi the Gisahila say the boss Tahubra.
Tao.
Okay, fine. So ngasi classy kanator zika so I delusion zika. Okay, fine. Thank you everyone. Thank you for the class. Good night.
Thank you, sir. Good night, sir.
Good night. Good night.
Tai sir.
Good night.